10, 11, and 12, those are the last ones on this page, is finding an appropriate sample size. So the formula for finding the appropriate sample size looks like this. N, they call it, of Z sub alpha over 2, like we did before, times the population standard deviation over the expected value of X, which is really the same thing as your mean. And then that whole thing is going to be squared. So it says many college graduates who are employed full-time have longer than a 40-hour work week. Suppose that we wish to estimate the mean number of hours worked per week by college graduates employed full-time. We will choose a random sample of college graduates employed full-time and use the mean of this sample to estimate our mean, mu. Assuming that the standard deviation of the number of hours worked by college graduates is 6.3 hours per week, what is the minimum sample size needed in order for us to be 99% confident that our estimate is within 1.2 hours per week of the mean? So, our sample standard deviation, 6.3. The mean, which is going to be our E of X, is going to be the 1.2 hours. We want to do a 99% confidence interval. So again, if this is 99%, we're going to do 1 minus 0.99, which would be 0.01. We're going to divide that by 2, which is 0.005, right? And so we're just going to plug that into our formula. We're going to do Z sub 0.005 times 6.3 over 1.2, and then we're going to square that expression. We are going to round our answer as a whole number, it says on these ones.
Both of those in, or just the Z, or the one on the right?
We're just going to do the one on the right. This is the formula, and then that's the formula with the numbers filled in. So the one on the right is what you're actually going to enter in. So Z sub 0.005. And click up a little higher and do times, or 0.63, or 6.3, I read it wrong. 6.3. Back that up. Okay, 6.3. Highlight that.
All of that.
Oh, we don't want the parenthesis because we want the parenthesis on the outside. It doesn't want to stop, does it? Try starting on the Z side of it and go highlighting it. Whoa. Still wants to do that. Well, if you hit the, let's see if we hit the divided by, if it just does the whole thing. Nope. Why is it trying to be difficult? See if I do it that way. Nope. Not want me to do that. Let's do this. Let's see if this will work. Parenthesis, and let's put the division first. There we go. And then we can do the Z sub 0.005 times 6.3, And on the bottom of our fraction, 1.2 parentheses squared. All right, it was not letting us highlight, so I hit the fraction button first and then type the top and bottom in separately. Did yours work okay?
Is that very good?
1.83? Yep. Yes. And you might not even have to worry about highlighting because of the order of operations. It's going to multiply and divide from left to right. So you might not even have to worry about the
Okay.
dividing.
So,
So 1.83, we're rounding that off to.
1.
Or not 183. No point, 183. Did I write a point? No. So that means if I were going to do this, I would want to survey at least 183 people. That's the minimum I'd want to survey. All right. Number 11, suppose a researcher is interested in estimating the mean systolic blood pressure of executives of a major corporation. He plans to use the blood pressures of random samples of executives of major corporations. Assuming the standard deviation of the population is 26, what is the minimum sample size needed for the researcher to be 95% confident that his estimate is within 6 millimeters of the mean? So, my standard deviation is going to be 26. My mean that I'm estimating, we want to use 6. And then we have a 95% confidence interval this time. So if we have 95%, 1 minus 0.95 would be 0.05. 0.0 to 5 divided by 2 would be 0.025, right? So in our formula, we're going to have z sub 0.025 times the standard deviation, which is 26, divided by our estimated mean, which is 6, and then we're going to square that. Let's put that in without worrying about the highlighting and see if we get the same answer. We get that all written down. All right, so let's do our parenthesis. Z sub 0.025 times our 26. Whoops, wait a minute, we had to click up above that. We don't want that down in our subscript. 0.02, oh, we need a 5 behind our 0.025. Okay, now click up. Times 26. And let's just divide by the 6. I want to see if it comes out to the same answer. Close your parenthesis. Whoops, got to do it behind your fraction though. And square that. The x squared, there you go. And hit equals. And 72.13. Okay, yep. Now, on these ones, when you do your calculation, you get 72.13. However, you want the minimum number of people. I always have to round these ones up to the next bigger number. If I only do 72, I'm not going to have enough because I need 72.13, so I'm always going to round up and say, oh, I have to survey at least 73 people then. Okay? All right, last one on this page. Executives at a supermarket chain are interested in the amount of time that a customer spends in the store during shopping trips. The executive hires a statistical consultant and asks her to determine the mean shopping time. The consultant will collect a random sample of shopping times at the supermarket and use the mean of the shopping times, assuming that the standard deviation is 27. What is the minimum sample size she must collect in order to be 99% confident that her estimate is within 3 minutes of my mean? So E of X is going to be the 3. And if I have a 99% confidence interval, 1 minus 0.99 would be 0.01 divided by 2 is 0.005, right? So, what am I going to punch into my calculator?
So 0.005 times 27 divided by
3, and then that whole thing is squared, right? Didn't know it. Oh, notice again, you didn't click up. Let's see, your fraction is right next to your 0.005. Undo a little bit more. Keep going. Okay, click up above and then do your times. 27 divided by 3. So it's not tiny. And then click behind there, close your parenthesis, and square. Now what do we get? So we get 537.4, which means then for our answer, if we get 537.4, we're going to round it off to 538, because I always round these ones up since I want the minimum whole number that satisfies my requirement. 537 wouldn't quite be enough. I got to do at least 538. Alrighty, that's chapter 7.